Hi, everyone, and welcome to today's webcast on how to build world-class AI applications with Labelbox. I'm David from the Labelbox team, and I'll be kicking things off. First, I'd like to present our speakers for today. We're excited to have Manu Sharma, our CEO and co-founder, join us, along with John Vega, our machine learning support engineer here at Labelbox. As a quick agenda of what we're covering today, we'd first like to share a few best practices based on what we've learned from our customers who are building sophisticated AI applications. Second, we'll be doing an overview of the Labelbox product as it relates to creating high-quality training data and operating a machine learning pipeline. Lastly, we'll be opening up for Q&A and taking live questions from the audience. With that, I'll pass it off to Manu.
Thank you, David. We are really excited to be presenting to all of you today. This is our very first webcast ever, and let's get started. We're living in the world that is increasingly powered by AI. At Labelbox, we have a very privileged view of the thousands of novel machine learning use cases. And nearly every single week, we learn about new ways AI is solving real-world problems. We can't wait to share with you some of our key learnings that we have seen working throughout with these numerous machine learning teams. To build world-class AI applications, you need basically three things. Number one is algorithms. State-of-the-art neural networks is available for free. We see thousands of teams mostly practice transfer learning today. That is, to use existing pre-trained models as a starting point and tune it to their bespoke labeled data. This generally enables teams to move faster and get reasonably performant models with lesser data quickly. Now, one amazing thing is that the state-of-the-art algorithms continue to get better, and they continue to be available for free in packages like PyTorch and TensorFlow. Second is compute. Over the last few years, we have seen unprecedented advances in AI computing, from better, faster algorithms to massively parallelized computing graphical and tensor processing units. The effective AI computation speed has been doubling every 3 to 6 months, which largely is unseen in a computing paradigm. Now, I'll invite John to share the third most important piece to build AI.
The common denominator across all these cutting-edge AI applications is the need for high-quality training data. To develop high-quality training data, machine learning teams need dedicated labeling tools for annotations and classifications. In the image on the slide, there are annotations of cars and people on the road. There are also going to be classifications, for example, where is the car going or what type of car it is. This information forms the training data. There are also a few different methods to develop training data. There's supervised model by weak supervision, synthetically, or strong supervision, or human labeled. Weak supervision techniques is considered to make lower quality labels and is typically more efficient, but at a higher abstraction level. Synthetically made training data is manufactured data. This is used in situations where real data is not large amounts or it is private information. Synthetic data can support teams create and test machine learning models without having large data sets of real data. And finally, human labeled training data can be the most precise, but is a lengthy process. Human labeling is the process of users manually annotating and classifying images for their specific use case. This can be the most accurate form of training data and is what Labelbox specializes in. These processes also can be used concurrently with each other. For example, let us use a supervised model with weak supervision and build a data set of weak labeled data. This is then sent through a machine learning model. The next step can be inserting the information to be fixed and refined by a human labeling team. These specialized labelers can then configure, correct, or delete the labels. In conclusion, training data is the fuel of an AI engine. What the data will look like and where the data is sourced are important questions to ask when developing data. Now, here's Manu to elaborate on training data platforms for AI teams.
Thank you, John. Labelbox is a unified training data platform for machine learning teams to quickly and continuously build and improve machine learning models. We created Labelbox because of our personal experiences of building training data infrastructure. For building software, you need GitHub-like tools to collaborate and manage software development with people. To build AI applications, machine learning teams need training data platform to create and manage training data easily. Labelbox enables machine learning teams to label data with internal labeling teams, as well as various outsourcing services, reduce human labeling costs by leveraging automation to their benefit, and most importantly, manage all of this training data activity that takes place in one single place. For thousands of teams, Labelbox is a place where all of their human supervision takes place. Now, let's learn some of the best practices for building world-class AI applications. Number one of the things that we learned from everybody talking to big companies, big and small, is that they have to spend a lot of time to understanding the problems that could be solved with machine learning. And that is the very first step in machine learning journey. And it is to choose the right problem and asking the question that, is the particular problem we're looking to solve a good use case for machine learning? Now, how can you know if a problem is potentially a good use case for machine learning? Is there an opportunity to make an internal process for a company more efficient, or you would like to use machine learning to power new products or services? Machine learning often has the highest ROI when applied to products and services. Second is to understanding the intent. Is the intent for your team to augment or enhance an existing manual workflow, or to replace the manual workflow entirely? These two things are very different and has very different ROI profiles. Third is to clearly understand the constituents of decision made by humans. What constitutes making a decision? Here's an example. A doctor making a diagnosis for a patient might look at a series of X-ray scans. Typically, these are all images. And then the doctor might have to also look at a patient history and comprehend that. And that typically is mostly text. If you look at any problem up closely, there are often series of micro decisions that leads to one single decision. The more you go deeper, the easier it will be for you to understand areas of highest impact that can be automated by machine learning. Answering these questions will often lead machine learning teams to come up with certain things that a model should predict. This knowledge leads to creation of an ontology. In fact, ontology creation and iteration are some of the most overlooked parts of a young machine learning team. We believe it is one of the most fundamental capabilities needed by high-performance machine learning teams in an enterprise. Now over to John for the second best practice.
After selecting the right problem, the second step is to choose your model type and environment. There are important aspects to think about when determining a model. First, where will this model be deployed? The ML teams will choose either cloud or edge. The cloud models are connected directly through cloud services, for example, Google Cloud or Amazon AWS. This quick access to data enables scientists and developers to quickly, easily build, train, and develop machine learning models. Cloud models use cases can range from self-driving cars to medical imagery, where access to cloud services are available. Edge models, on the other hand, are not connected directly through cloud services. Typically, these models developed and trained in the cloud and uploaded onto a device close to where the data is generated. This method enables quick and flexible models, but performs the algorithms close to the data source. For example, an edge deployment could be a security camera in a warehouse, or a tractor in the middle of the field where there's limited or no internet connection. The second consideration is, what will the training data look like? Will the model have segmentation or bounding boxes? To decide which tool to use, the ML team will have to think about the final model. For example, if a car is driving down the road, most likely the ML model will not have to outline the car. A bounding box will do just fine. On the other hand, if a model needs to find the exact shape of a figure or a leaf or something like that, segmentation is far more accurate. It is important to think about the end goal of the model, where the model will be implemented, and the types of annotations in place. To be clear, Labelbox does not develop its own ML models. It is an interface for creating and managing training data. Now here's Manu to elaborate on training data.
Thank you, John. The third step is one of the most important pieces when thinking about a successful AI practice. It is the creation and management of your training data. Most people believe that outsourcing labeling gets the job done. That's simply not true. In fact, this is the most common misheld opinions shared by amateur machine learning teams. What we see from production machine learning teams is that they operate a very complex machine learning pipeline in which training data infrastructure is a foundational component. A great training data infrastructure has a few attributes: collaboration, where teams can label data with internal domain experts as well as outsource to various third-party labeling services. Second is training data analytics. Understanding quality of your training data is utmost importance, because in this endeavor, if you input bad labeled data, the model will perform badly as well. In addition to understanding quality, it's also important to understand key statistics around your training data that helps machine learning teams to iterate faster. Third and most important is also owning the training data. It is often our machine learning teams inside companies are working on some of the most proprietary data sets. And on top of the most proprietary data, they're labeling it in a unique fashion, which often constitutes to be the core IP of a company. And it is really important for teams to have full ownership of the training data as they go build these AI models. Now, let's go on to the next step, where John will share a bit more about quality assurance.
Once you've organized your data, the labeling effort begins. And this is the starting point of training your ML models. Model accuracy is achieved in several ways: high volume of training data, high quality and accurate labels, distribution of data sets, and data sets that are similar to the production use cases. Training data quality is one of the biggest challenges most ML teams face. When teams use outsourced labeling, labels are sometimes returned a bit off, missing, or altogether incorrect. This is why having quality assurance processes in place to continually fix and improve labels is a necessity. This includes having a feedback loop to help improve your labeler's performance. Now let's say we have a data set of chest x-rays. An image of the chest x-ray is queued, labeled, and then can be approved or unapproved by a radiologist. This is a basic example of checks and balances system to ensure only the highest quality of training data is submitted. Another important aspect of quality assurance is quality control. It's best practice to have a good distribution of data. If your model is supposed to distinguish a tree from a car, but the training data set is 90% trees and only 10% cars, this will lead to an inaccurate model. Overall, quality assurance is essential to create accurate and reliable training data. Next, we will move on to the Labelbox demo. This is where Manu will show you how Labelbox supports users to create, manage, and own their training data, as well as quality assurance. So if you have any questions so far on anything that we have covered, please go to the bottom of the screen and insert your questions into the Q&A section. And Manu will bring up the demo in 1 second. And there we are. Here's Manu.
Thank you, John. And this is the fun part. So please do ask us questions so we can cover them at the end of the demo. This is Labelbox dashboard. So when you sign up on Labelbox, you will basically see the same screen that I'm showing you here. And in fact, you will also see some example projects. Now in Labelbox, nearly all of the training data activity happens inside a project. Project is designed to be the environment where you are creating all of the training data needed to train a particular classifier model. Let's go ahead and see how to create a new project. So I'll press a new button to create a new project, enter project name. Sometimes it's important to be able to share project descriptions, especially in a large company where lots of people are creating all kinds of projects for training data every other day. It's a great way to search for projects when you access them later after that. So we'll skip it for now. Now the second step is to attach data set. Labelbox allows you to upload data from local computer for quick R&D projects, or simply you can connect to your data in an Amazon S3, Google Cloud, or really anywhere on the cloud or on-prem infrastructure. In fact, some of the production teams are continuously streaming data from their cloud into Labelbox via APIs. In this example, I'm going to just select an existing data set from here. So this would be an X-ray data set that we've attached here. One thing you'll also notice is that Labelbox allows to attach multiple data sets into a project, and in fact, reuse the data sets across multiple projects as well. This is a nice flexibility for machine learning teams to reuse their data for newer models. Once you've attached a data set, we'll go to the last step, which is to configure the labeling editor. Labelbox is powerful and extensible in a sense that we provide some of the most powerful labeling apps for text, images, video, and geospatial data. But more importantly, your teams can actually extend Labelbox with custom SDK. So if you ever find a unique labeling problem in your company and it cannot be there is no off-the-shelf editor for it, you could use our SDK and literally build that app perhaps like in a few hours using JavaScript and HTML and install it on top of Labelbox. In this demo, this is an image. So I will be, I wanted to particularly show you the image segmentation. So we'll be going with the editor that is called image segmentation and configure it. Now, as we mentioned before, ontology creation and management is one of the foundational capabilities for high-performance machine learning teams. And when the last step for creating projects is to add and apply an ontology to this project. So what you see here is objects and classifications. Because we are in computer vision domain at this point with the images example, you could easily customize and add an ontology that you see fit. So in this example, we will be labeling a couple of areas of diseases. So I would just simply add a name, pneumonia. And as you can see here, there are a couple of labeling tools that are available for your use. You could choose from bounding boxes to polygons, polylines, points, or segmentation toolkit. Now, all of these ontology creation can also be done via API and programmatically. So we have many customers who are programmatically creating these projects via API and launching those campaigns with internal teams or outsourcing workforces. You could always edit these ontologies anytime when the project is live. Now, it is also very easy for you to kind of add different kinds of ontologies. So for instance, let's say if you wanted to add a global classification, this would be to, let's say we wanted to ask if the image contains other signs of diseases. Yes and no. And this is a binary radio checklist. But if I had a couple of tags that I wanted to add, I would use checklist option. And then also, if we are labeling with pneumonia with segmentation, so let's say on the right, we are previewing our labeling editor. These segmentation tools are like this. You could, of course, do full image segmentation with instances support as well. But in this particular example, we want to stick with bounding boxes. And not only we want to create the bounding boxes, but we actually want to capture some more metadata about that bounding box. So you can actually come here and go deeper into that particular object and add a extra nested classification, what type of pneumonia this is. There we go. So now we create a bounding box. We will be asked to further attach a metadata about that bounding box. Labelbox is extremely customizable. You can create any number of complex ontologies, whether it's full classifications or in full object detection or semantic segmentations. Now, oftentimes you would be working with large labeling teams. And for that, let me invite John to share how to use instructions. You can attach labeling instructions right here as a PDF file. And when you attach this PDF instruction set here, the labeling teams will be quickly able to access that instruction set. They can refer to the good and bad examples, and you can always come and edit those instruction set anytime during the project is set up. What we're going to do is press confirm once our ontology is set up and complete the setup. Now, within a few minutes, what we've done is created a project, attached a data set, applied an ontology. Now, the next thing for us to do is to add people. Now, as we mentioned before, Labelbox is extremely flexible. We allow you to work with internal labeling teams as well as external workforce. So in this example, I have lots of people in my organization that are already added to this project because they are all admins. I can assign them different roles and they have different access controls for different projects. Now, in the same view, I can actually outsource this labeling project to an external workforce of your choice. Labelbox offers fully managed labeling service directly inside your projects. And all you have to do is simply add the unique ID that we will provide you as a customer and outsource that to Labelbox workforce. Now, this is the power that machine learning teams have. For quick R&D projects, they are able to label data with internal teams and understand if this is the right technique, if their models are, if the data they are capturing is yielding great model performance, and they can also outsource it and as they go into production scale. Now, I'm going to go and open up a new project that already contains labeled data so we can look at some of the advanced features on Labelbox. Here's a webinar demo. And this is a project that we were just labeling yesterday with a couple of people. So when the project is live, as a machine learning team, you're going to see some kind of key statistics about your project. It's your progress, like how much the data has been labeled, how much is remaining. More importantly, you're also going to see statistics around your training data, like how much things have been annotated in your data. So in this example, we are labeling a couple of, this is a self-driving car data set. So we're labeling all kinds of things that a car could potentially see. And these statistics are particularly important for machine learning teams because if a machine learning team can know that there are literally no examples of sand or ground animal or mailbox, their model is likely not going to be able to detect that or learn how to detect these objects. So before even they train a model, they should perhaps like add more data that might contain mailbox examples or phone booth examples. This simple insights can make machine learning teams move incredibly fast because they can bypass the model training and deployment phases entirely. Now, more importantly, all of the training data that your teams are creating, you can come to the label browser and review them in real time. So here's an example where we are basically seeing all of this training data that has been labeled, and we can view them here. Let's turn on their object classes. And if you desire to, you can even make edits to it right away. You can even approve and reject these labels. In fact, you can also slice and dice your label data based on a variety of attributes. What kind of data this contains, like this is from data set 1. I want to find a label data that also perhaps contains certain ID. Let's actually try this. Let's find training data that contains car. So now you can actually search across all of your training data as well and slice and dice to your needs. Machine learning teams particularly love this capability so they can hone into the right classes and inspect them as things are being labeled in real time. Now, one of the things we didn't share yet is how are the data labeled. So when you attach data sets and basically when you kind of set up a whole project and kick off the labeling, every single person who has access to this project in the members, whether it's individuals inside the company or an external workforce, they can come here and press start labeling. Labelbox automatically distributes the tasks dynamically and in real time to all of these people. So you never have to ever worry about allocating or dividing the data to different people and managing that kind of operations. It's all done for you by Labelbox automatically. Now, let's move on to quality controls, which is a very big part of Labelbox infrastructure. Creating high quality training data is really important. And we see machine learning teams spend a lot of emphasis and a lot of energy into ensuring that their training data is of highest quality as possible. In Labelbox, we offer quite a few ways to do quality assurance. Number one is consensus. Especially in tasks where there is a lot of subjectivity and sometimes there's not the right answer, you might want to use consensus as a mechanism to understand disagreement in your data. An example would be like doctors in some certain domains when they're diagnosing when they're looking at medical imagery, they can disagree as much as up to 40% of the time. So if you're a machine learning team and you're creating training data that has so much of disagreement, you are going to propagate that to those models, and that is not ideal. So your teams can come here and simply say, you know what, I want 100% of my data to be labeled 3 times by different people. Labelbox will automatically distribute these tasks to the right people, capture their assessments, and even provide you the agreement scores if available. This is a great way to understand disagreements in your data. And these disagreements often will pop up right here in your label browser. As you can see here, some of my images has about 80% of agreement. So I can look at all of these examples and find where people are disagreeing and perhaps take actionable insights. Typically, those actionable insights are to improve the instruction set and retrain your workforce, or it is to actually come back to the settings and edit your ontology. So you can quickly come here back and say, you know what, my teams are confusing a couple of these classes. So perhaps we should rename those classes or remove some of them entirely. So these are kind of the insightful actions that we see most of our machine learning teams take. And these insights are derived from quality tools like this, a consensus. Now we have benchmarks as well, which is a absolute measure. It's an absolute way to measure quality and quiz your labeling teams. When you have benchmarks turned on, you can dynamically seed labels that are 100% accurate. And you can continue to do so as you find edge cases in your data sets. So all you do with benchmarks turned on is simply star these labels, and you're basically telling Labelbox that these labels are 100% accurate and that we should be quizzing people on these images and reporting their assessment on this reference image. You can continue to create benchmark labels as much as you like, as many edge cases that you uncover in your training data. This is a great way to ensure consistency when the labeling projects are ongoing. Third and final step is review. In many domains, what we see is machine learning teams have a group of experts that are ensuring or that are approving or rejecting all of the labels that comes from a variety of different teams. Take an example where if a company is building a very bespoke machine learning model to understand the type of a plant, what we see is that the group of agronomists who are ensuring that every single label that goes into the model is reviewed by these expert agronomists. So what you can do is simply turn on a review step, and either you could do random audits, or you could have your review team review every single label that comes from a initial labeling team. And all of your reviewers that has access to this project will be able to will be able to start reviewing and approve or reject labels as they see fit. Now, machine learning teams or labeling operation managers can come here into the label browser and filter the data based on a variety of these tags. So if you want to find labels that are particularly bad, you can select these labels, and you can decide if you want to delete them and put it back into the queue. Now, here's an important aspect. When you put the labels back into the queue, you can choose to keep those labels and ask your team to make edits instead of starting from scratch. Now, we see many teams with their bespoke tools that they have built that they essentially kind of throw their labels and start from scratch every single time. And that is one of the major ways one of the major reasons why human labeling can cost so much. And that is precisely because of that. What you want to do is apply rework to your training data. You want to have workflows where you're constantly increasing quality of your training data by making little edits over time. And Labelbox has amazing workflows to ensure that you're continuing to applying rework on your training data so that you can get to high quality data as quickly as possible. So what we covered is a couple of ways of quality assurance. Now, let's look at some of the really advanced ways on how machine learning teams automate labeling in Labelbox. Now, in this example, we had labeled about 60% of the data. And as John mentioned, that most teams train their models with noisy labels from weak supervision, synthetic data, or sometimes ground truths that is created inside Labelbox. Once you have a model trained, even it performs poorly, it fundamentally has knowledge about understanding certain classes. What you can do is you can have your model make predictions on all of the unlabeled data that you have inside Labelbox. And these model predictions can be given to your labeling teams, and your labeling teams are instead of labeling from scratch, they're essentially making reviews on the model predictions or making edits to those model predictions. And that is one of the best ways to speed up your labeling processes. And the way you do that is you have your model, you essentially turn on this model assisted labeling feature on here, and import the model predictions via API. And as soon as the model predictions are imported successfully, all of the labeling teams will instantly be able to start to see these predictions come up in the image. So here's an example where these predictions are shown up, and instead of labeling from scratch, these teams are, my job is here to essentially review them and ensure if there are corrections to be made, I can make some corrections and submit those corrections right there. We have seen teams to speed up labeling by as much as 80% in some of their tasks with model-based pre-labeling. Now, there is yet another way to automate or automate labeling process, but more importantly, go into production as quickly as possible, and that is real-time labeling. In real-time labeling, your models, as they're in production, you can actually go into production with poor performing models and route all of the tasks that your model is not confident on into Labelbox, where a dedicated team is reviewing those events and sending it back to your user application as quickly as 5 minutes. This is an amazing way for machine learning teams, especially with models hosted in the cloud, to go into production as quickly as possible with a fault-tolerant system where they can fall back into human-in-the-loop workflow when their model fails. Now, let's go over some of the other aspects of the product. When all of the labeling is happening, your machine learning teams have transparent view into human performance. Whether you're working with internal labeling teams or external workforce or labeling services, your teams can see all of the data about how much time does it take to make a label. And this time is recorded on basically very precisely on the screen. And this is a great way for high volume production teams to ensure and to standardize how they're going to pay for labeling services. Because if you have all of the data about how people are performing across all the workforces, you can kind of get to insights on which teams perform poorly, which teams perform better, and ensure that your spend is being allocated appropriately. Now, your machine learning teams can, of course, export data from in a JSON format ad hoc right here in the UI, or you can use our APIs to programmatically export data in real time. We support webhooks where if you have a real-time machine learning pipeline, you could be constantly streaming data into Labelbox and streaming out of Labelbox. Or you could also make programmatic requests to export large chunks of data ad hoc. Now, with that, we will conclude the demo. What you saw here is a very tiny slice of Labelbox. We only went through image labeling. Labelbox has amazing tools for text, natural language processing, as well as video annotation and geospatial data. And perhaps we'll take another webcast to go deeper into other labeling tools and workflows. With that, I will hand off over to John to continue to go over next best practices.
So we've covered the 4 of the 6 best practices for building world-class AI applications. Now I'll share the last 2. For any AI application, time to market matters. However, getting your machine learning model to 95% accuracy can be a costly and also time-intensive endeavor. So what we're seeing is in the market is companies are going into production with largely untrained models. For example, a use case could be categorizing receipts. The company would receive data from users and input that information into the machine learning model. At first, the machine learning model will look at the receipts and not be able to tell most of the items apart. A large group of human labelers will then correct and fix the labels and iterate the model. While the process is slow at first, over time the model will become more and more accurate. The end goal would be around 95% accuracy, and with a much smaller group of labelers fixing the last 5% of labels. The human workforce is used to enable accurate labels are being fed into the AI application. This method not only allows you to put the machine learning model into production quickly, but the human workforce is also concurrently training your models and helping the models increase in performance over time. And so now we will discuss iterating and improving. The last best practice for deploying successful AI products into production is to have a continuous, iterative pipeline to improve your training data. As you deploy into production, you'll be receiving new, real-time production data that you can use to further train your models. Your production use case may shift and evolve over time, so continually feeding in new data into the model is necessary to not just improve, but maintain the consistent model accuracy. Labels from machine learning models can be inserted directly into Labelbox, as Manu shown, as predictions. Also, a model might have to change over time. So let's use the predictions model that we showed earlier. There could be a new feature. Let's say we need to add a semi-truck. And then with Labelbox, a user can add annotations and input a nested classification into the image editor, adding a tool of what a semi-truck could be, and then adding a classification of what kind of semi-truck, what the logo has, etc. This is just a basic example, but changing the ontology to reflect a difference in use case or end goal further assists machine learning teams to improve their models. This method of iterating and changing the ontology of a machine learning model is essential for accuracy, improvement, and precision. Now here's Manu to bring it all together.
Thank you, John. We have covered a lot of ground today, and I hope you enjoyed today's session. This is our very first webcast ever, and I truly appreciate if you could share feedback and anything you'd like us to cover in the next one. And with that, thank you very much, and please do share some questions as we go into Q&A.
Wonderful. This wraps up our webcast for today, and we hope you found it useful, and thank you for attending. As a reminder, you can sign up for Labelbox in just a few minutes and try out the tool for free, or you can contact us to schedule a demo. We'll be also sending you a copy of the webcast shortly afterwards. We hope everyone's staying healthy and safe during this time. We'd now like to open up for Q&A from the audience. We have a bunch of questions here, and thank you for submitting them. So first question, it's a little bit more of a technical question here, but do I need to import my own ML model into Labelbox?
No, you don't. So basically, you're importing your data into Labelbox for labeling. But if you're using model-based pre-labeling, your models reside in your environment, and basically you create these predictions, and you're importing those predictions back into Labelbox. And this is actually great because many machine learning teams will have an ensemble of machine learning models that makes one prediction. So you can kind of, it doesn't matter, however you generate those predictions, you can just import them by API.
Great. Thank you, Manu. John, anything you wanted to add to that?
I was just going to say that I would also reference the Labelbox docs. It's very, very helpful for understanding exactly how to use Labelbox in your machine learning pipeline, as well as if you ever have any questions and you're on the Labelbox website, on the bottom right-hand corner is essentially like a text bar that you can ask people like me on the MLSE team questions about how to do this or how to format, and we can definitely help you anytime.
Great. Next question here is, what industries and use cases is Labelbox primarily used for today?
We see all kinds of industries in Labelbox. I mean, I think, as I mentioned in an earlier part of the presentation, like it's really cool to see all kinds of use cases, from sports analytics to manufacturing and inspection, and of course medical imaging, all the way to like very high-end inspections and like geospatial data. Like Labelbox is basically used in nearly every single industry imaginable that has computer vision applications today. In addition to that, we are also used in nearly every research organization in the United States that has a computer vision program. So yeah, the use cases are really endless. I think it's if I were to say, like, we certainly see a lot of interest from companies, like for enterprises, where they, like enterprises in insurance and inspection, transportation, and so forth. But really, it's pretty uniform across all industries at this point.
Great. Next question here. Could you share an example use case of a company that's like best using or fully leveraging Labelbox?
Yeah, that's sure. So I think one of my favorite examples is a company in the United States. This company has is in trucking fleet management business, and they have over like 1 million dash cams that are installed inside these trucks, commercial trucks. And what happens is, like, their fleet managers operate like a couple of, obviously, a fleet of trucks, and typically there are lots of accidents that happen basically on a regular basis. So these dash cams have not only cameras facing outside, but facing inwards as well, so they can look at the driver. And these dash cams have neural nets. So these neural nets now can not only detect what's going on outside, like if there was cars or bad turns, but also the driver behavior, like was the driver sleepy on a phone, or kind of like smoking a cigarette, whatever that be. And so this company now essentially offers a product and service where the fleet manager, anytime there's an accident, this fleet managers can get alerts right away that there was a bad behavior or accident, and this was potential cause for it. Now, this company uses Labelbox not only to create those initial models that gets deployed to these sensors, but those models are nowhere close to kind of like 99% confident or performant, because there's so much diversity, like night and day, different parts of the country, and snowy conditions and so forth. So they stream, like any time a neural net is unable to make a decision, that event is streamed into Labelbox. They have hundreds of people full-time, 24/7, reviewing those events. And within 5 minutes, those events are sent back into their fleet manager's dashboard. And it's an amazing kind of orchestration, or really, of the training data. Not only they're in production today, and Labelbox is used right there in the real-time pipeline, but they're also creating training data to improve their model performance as they get more data. So the company short-circuited, like basically it went into market like in a month or two. Alternatively, they would have to continue to collect data for a year and train a model and see if their model works and then go into production. And I think that's an amazing way, a new and amazing way for companies to go into production today, especially if their models can be connected to internet.
Thank you, Manu. Next question here from Zach. Thanks for asking the question, Zach. Are you able to add to the ontology after it's been established?
Absolutely. You can add features. You could add objects and remove objects basically anytime in a project. You could rename them as well. So you have like a full control over the ontology, and it's really important because typically people uncover so much new learnings when the training data is being created, all the edge cases and so forth. Like it's incredibly hard, like if you're solving a real world problem, to come up with all possible options that should be labeled. And so we just see this over and over again with production ML teams, that they continue to iterate their ontology during their training data creation.
Great. Question here too from Ben. You mentioned using labeling automation to reduce costs for customers. What automation do you use, and how does it affect the quality of the labels?
Yeah, there are a couple of ways that our customers use automation. Number one is model-based pre-labeling. So they have their existing models that obviously perform better than any other generalized model that make predictions on their data. And essentially, they have the model make first judgments on nearly any unlabeled data. And depending again on a task, the nature of the data, like whether it's object detection, classification, or segmentation, typically the cost of correction of labels is is lower than cost of creation of those labels. And so having your models participate in the labeling and have your human teams basically review them generally is a pretty general and a great way to speed up the labeling process. And because in Labelbox, all of the metrics for human performance are kind of transparently available to you, and most of our ML customers pay the human services on the total time labeled on Labelbox, you're basically benefiting on automation because you're reducing the time that it takes for people to label the data. Now, we also see customers use active learning. So Labelbox has ability for you to prioritize a queue dynamically and in real time. So wouldn't it be neat, like if you could find a way that you could find a way to eliminate labeling in the first place entirely? I mean, that would be that's an ideal scenario. And again, with your models, you can use your the model's knowledge and understand where the model is really weak at, and what data should you be trying to prioritize for labeling. And we see quite a few production customers to basically continue to remove data that shouldn't be even labeled, because that is not going to move the needle in their performance, and rather prioritize the things that will actually improve their model performance as quickly as possible. And so I think with both of those kind of techniques, our teams have seen as much as up to like 80% automation.
Great, thank you, Manu. Another question here. I think we have time for about 2 or 3 more questions here. We'll try to go for a few more. Question is, how'd you come up with the idea for Labelbox?
Oh, sure. I'll be very quick on that. I was at a company called Planet Labs. Planet Labs is an American company in San Francisco that operates over 300 small satellites in low Earth orbit. And the company can image the entire Earth landmass every single day. So basically think of like, any part of Earth, there are hundreds of images being streamed nearly every other day. And our goal was to, instead of selling data, rather sell insights to our customers. And these insights could be, how much traffic there is in a shipping port, or what does a deforestation look like in Brazil or different parts of the country, and basically like anything that you could understand from a global image that updates every single day. And we probably have, the company has probably one of the largest computer vision pipelines that I've seen. And in order to solve nearly any problem, we would have to label data and either work with domain experts who have been doing that work for decades manually as an analyst, or we would have to outsource labeling. As a company, as a machine learning team, we spend a crazy amount of time and resources to build training data tools and infrastructure ourselves in order to consistently build models and solve business problems. And it was far too much big of an investment. And we thought, I thought that this, given that the world is sort of moving into a world where we're kind of moving from software 1.0 to software 2.0, where really to big intelligent applications, you fundamentally need labeled data, that the tools that I was seeing being built would be applicable to a broad range of industries. And that really kind of got us all started a few years ago.
Thank you for that. Yeah, it's a great story there. And there's a bunch of questions on like video. Maybe we can talk about video holistically first, and happy to also, as you mentioned, Manu, we can throw another webcast specifically dedicated to that.
Yeah, absolutely. So, Labelbox supports video labeling, and what you can do is import directly MP4, MPGs, or .avi like video files into Labelbox. And while we support nearly any frame rate, but what we recommend is people to downsample the video to a frame rate so that their frames look a little bit unique, so that you're not kind of creating a kind of duplicate data all the time. And you can do frame-by-frame classifications, action recognition, as well as object tracking. So we'll be very happy to kind of go deep dive into that. Or please do reach out to us online on labelbox.com, and there's a chat icon there. John often is on the other side of the chat icon, so we'll be happy to give you a deep dive demo on our video capabilities.
Sounds great. I think this wraps up the majority of some of the questions here. We're going to be sending out the recording, as well as there's some other questions too we'd be happy to follow up with. And we'll also be submitting a quick survey. We'd love feedback. And thank you very much for attending this webcast.
Yeah, thank you, everyone. This is, again, our first webcast, and we're very delighted that you all spent time with us today. And we want this webcast to be for you. So please do share like what you like to see us present next time. Apart from talking AI, we could also mix electronic music and perhaps bring some other guests from AI industry. So we have a broad range of capabilities here at Labelbox. And stay healthy and safe, and thank you very much.
Thank you all.